All right, guys, we're gonna do a couple more examples together. That way we can get the hang of this, and then I'll let you practice some more on your own. For letter A, the base is the same. We're multiplying across, so we're gonna add our exponents. If we add a positive 5 and a negative 5, we're gonna have nothing, 0. So our base is staying the same. We added those two numbers and got 0. So that means that this answer is 1. Let's look here. We're keeping our base the same. We're going to multiply across, so we're adding our exponents. So we're going to get 2 to the negative 5th power. Now in our directions, it says that each expression should be written with positive exponents, which means that that is not simplified. I need to throw that over 1. I'm going to send that into the denominator. So I have 1 over 2 to the 5th. And I think 2 to the 5th is 32. So I'll write 1 over 32 here. Not used to writing on such a small board, but it's pretty big considering it's in my house. All right, here's a great example because this time that negative exponent is in the denominator. So you're not just seeing me move everything to the bottom, you're gonna see me move it up this time. And again, that 1, which is a placeholder a lot of times, we're not gonna need it this time, and you'll see that. So right now, we have e to the power of negative 2 on the bottom, in the denominator. I'm going to send that up. We don't need to flip-flop the 1. It can stay there, because 8 squared, 8 to the power of 2, is 64, which is the same as 64 over 1, so we don't need it. So we're all done there. Let's look at this next one. All right, remember, power to a power, we multiply. So we're going to multiply our numbers there, keeping our base exactly the same. So we have 3, and then 3 times negative 2 is going to give me negative 6. Can't have a negative exponent, though. We're going to move it to the denominator. So I have 1 over 3 to the 6th. And let me check to see what that simplifies to. 3 to the 6th power. 729. Didn't guess that one. So 1 over 729 is your simplified answer. Let's look at this next guy. All right, power to a power, we multiply, keeping your base exactly the same. So there's your base. Negative 1 times 5 gives me negative 5. And just like that guy, we're going to do the same thing. Throw it over 1, send it to the denominator, giving us 1 over 2 to the 5th, which is 1/32. Ooh, this one's very similar to this one. All right, so we're gonna take this guy, we're gonna move it up. And then we have 6 squared on top over 1. 6 squared is 36. And we don't need to keep that over 1. So 36 is our final answer. All right, very nice. So for this one, I'm first going to use the properties of exponents, and then I'm going to explain it a little bit differently. So if I'm using my properties of exponents, when I divide, I know I need to subtract. So I have the base of 7, and then it would be 3 minus 5. So I'm going to write that out just so you can see it. So the base of 7, 3 minus 5 would give me 7 to the negative 2nd power. I'm going to throw that over 1, send it into my denominator. Got to keep that placeholder up top, that's why I have that 1. And then 7 squared, which would then again simplify to 1 over 49. Now let me show you something a little bit different. So what I was trying to explain a little bit in some earlier lessons is that you can look at this and kind of do that simplification in your head. Once you get used to it, thinking about what it would look like longhand. So what I mean by that is, if I wrote this example longhand, it would be 7 times 7 times 7, because there's 3 on top, over 7 times 7 times 7 times 7 times 7 on the bottom. Okay. Now I know that things that are on the top and the bottom, I should simplify. I can cancel out. So I'm going to cancel out what I can. These would cancel out. These would cancel out. These would cancel out. Now I'm left with 2 7s, but they're on the bottom. So that's why we need the 1 up top just to keep that placeholder. And then 7 times 7, or 7 squared, is 49. So whichever way you look at it, whatever makes more sense to you is fine. These are the properties and these are the rules, but they apply and there's a reason why we do this. So hopefully that helps you a little bit, and we'll go from there. All right. Again, there's a couple ways to do a lot of these problems. So whatever way works for you, as long as you're using the properties correctly, you should be perfectly fine. Our base this time is 6. This is -3 over -5, I believe. Mine's a little bit, let's double check that. Yep, -3 over -5. So if we use our properties of exponents, we're going to subtract them. So we have the base of 6. We have -3 minus -5. When we subtract a negative, we add it. So I'm going to put a plus sign here. So that's going to give me 6. -3 plus 5 is going to give me a +2. And 6 squared is 36. All right. Lastly, let's go ahead and finish this guy off. So I'm going to do what's inside the parentheses first. I have the same base. I'm multiplying across, so I'm going to add my exponents, giving me 4 to the 5th power, all taken to the power 0. Power to a power, we multiply. 5 times 0 is 0, so we have 4 to the 0 power, and anything taken to the power 0 is 1. You could have just told me right away it's 1, but that's okay.